Congratulations, you made it to the second set of the second topic in the end of year 2020 COVID-19 mathematics IED lesson plan extravaganza palooza. Solving equations. There's two parts to this bad boy. Must be an important thing. So, as usual, start off straightforward. So, our goal is this. Somewhere in the universe is a number that when you plug it into here, makes this true. Not every number makes this true. If I pick 5, for example, and I stick it in here, 5 times 8 is negative 40. That is not equal to 11. So when we say we want to solve it, we want to find the one number, and in some cases there's two numbers and many numbers, but for the ones we're doing, the one number that's going to make this a true statement. So basically it's all about doing the opposite and getting x by itself. I use x in all these just to be consistent, but it doesn't have to be x. It could be any letter. So for example, negative 8 is being multiplied times x. So to get rid of it, I do the opposite. I divide both sides of the equation by negative 8. Why not 11? Well, because I want to get rid of this negative 8. And by getting rid of it, this is what I do. Negative 8 divided by negative 8 is just 1. And 1 times anything is just itself. So this makes this really 1 times x, which means I can just write it as x. Equals 11 over negative 8. Now there's a lot of ways you could write that. If you could write that as x equals negative 11 eighths. You can, anyway, but this, by the way, right there, you're done. You found the number. Negative 11 eighths. Either one of those. That's it. That's it. Okay, so let's try another one. All right. So here, this comes up. You'd be surprised the things that make people confused, right? Because you're looking for a pattern. What's different about this? Well, the only thing that's different is the thing with the x is written on the right side here when it was written on the left up here. Don't panic. You got a couple choices you can do here. One is you can remember that you're just solving for x anyway and just do the problem that way. Or if it really bothers you, there's no law in mathematics. If a equals b, it's perfectly fine to write b equals a. So if it really bothers you, you can set it up so that it's on the other side. The more complicated the equation becomes, the little trickier that becomes. But in this case, you could switch it. So I'll look at it both ways. I'm not going to do this every time. But I'm going to look at first like we would have done it up there. Just, I need to get x by itself. So I'm going to get rid of this 2. How? By dividing both sides by 2. This gives me 1 times x, which is just x, and 9 over 2. You can leave it as an improper fraction. The phrase improper fraction is unfair. There's nothing improper about that. It's a perfectly fine number. In fact, it's more useful than mixed numbers. But don't get me started. So that's your answer right there. If you wanted, then you could write, okay, x equals 9 halves. That's fine too. If you wanted to in the beginning, like I said, switch them here and say, all right, 2x equals 9. There's nothing wrong with that. And then divide both sides by 2 and end up with the x equals 9 halves. Right. I don't mind this as an answer or either one of these. The order doesn't matter. If the question says solve it, really it's the 9 halves you're giving as the answer anyway. All right. So what's up with this one? Remember, we always want to do the opposite. So here, x is not being multiplied by a number like it was here. It is being divided by a number. So the opposite of division is, of course, multiplication. We're going to multiply by 5 here and by 5 on the other side. Multiplying by 5 here makes that 1 that we're looking for, so you'll leave us with just x. Over here, 9 times 5. That's 45. And you're done. Let's try this one. All right, so what we see that x is being divided by something, so we know we need to multiply, and the thing it's being divided by is negative 7. So I multiply by negative 7 here And I like using parentheses, actually. -7 over here. I would actually write just, I don't know, it just cleans it up for me. So here, these two are going to divide and make 1 anyway. So I end up with an x. Over here, I have -7 times -3, which is going to be a positive 21. So the answer here is x is equal to 21. And by the way, if you want, and not if you want, I recommend highly that you check your answers. For example, here, I could take that 21, plug it in for x. So let me get rid of some of the stuff I wrote before. You should really not walk away from this wondering if you got it right. Like, you'll know, because if you have 21 and you plug it in here, that means you have 21, because we did substitution, 21 divided by -7. What is that going to be? 21 divided by -7 is -3. Hey, that equals what it says it should equal. So this is the solution. If I had gotten it wrong and come up with, 14, well, 14 divided by -7 is -2. That's not -3. So that must not be the right answer. So you can always check your answer by plugging it back in. All right, on to part 2. So here's the last possibility. What if the thing that you're looking for is in the bottom? These are, at first, the trickiest. Like, what? What am I going to do? What do I do here? You don't want it in the bottom. You don't want that thing down there. You can't, no. So here's what you do. I am now going to give you a little trick. My friends, this is a perfectly legal mathematical trick. And you should know that 10 is the same as 10 over 1, right? Okay, so anytime you have what's called a proportion like this, 2 fractions equal to each other, it is perfectly legal, trust me on this one, to switch opposite corners. That's it, just switch them. So for example, in this case, I can write x here and the 10 down there. And x over 1 is just x. The 1's just there to kind of help you see that it's a proportion. So I'm done. But you got to remember that's the trick you're going to use. Okay, so now I'm going to stop calling it a trick for a second, and I'm going to do what I should do as a teacher and explain to you why this works. All right, so what I do, let me find some colored pencils. No, actually I'll do it on a separate thing here. And I got at least a couple colored pencils here, right? This guy. Come on, I have like a whole box of this stupid things, don't I? There we go. Okay. So I start off. I'm going to explain to you why this works. 10 equals 7 over x. Alright, so what I really do is this. I do 2 things at once. On the one hand, I don't want the x in the bottom, so I multiply both the top, both sides by x. Boom and boom. Perfectly legal, and it's going to cancel the x's here and put it in the top over here. But at the same time, I don't want the 10 over here. I got to get x by itself. So then, with a different colored pencil, I show that what I do here is I divide both sides by 10. Okay, so what happens is the 10's cancel over here, and it'll leave me with just x. And on this side, the x's cancel, and I just have 7 over 10. Which goes back to, if I have 10 equals 7 over x, I can just switch these two. X equals 7 over 10. Perfectly legal. Perfectly legal. So let's try this little trick here. So I can switch the x, which is in the bottom. I don't really want it in the bottom. The denominator. Sorry, math people out there are freaking out because I'm calling it the bottom. The denominator. This is the numerator. Math people love to make math hard by using all the correct vocabulary. They're not nearly as hard if you just use regular words. But anyway. I can switch these two. So negative 6 over 2 equals x. And in this case, I can actually simplify this. Negative 6 divided by 2 is negative 3. How about this one? Nah, don't switch anything. The x is already in the top. So this is deliberately not like one of these. This is kind of getting you to think for yourself. The x is up there. It's being divided by negative 4. So I need to multiply both sides by negative 4. So that I have x equals 10 times negative 4, or x equals negative 40. And here, they're multiplying x by negative 6, so I want to divide both sides by negative 6. And I end up with x equals negative divided by negative is a positive, so positive 7/6. There you go.